It is Mars, the fourth planet from the Sun, a world wrapped in myth, mystery, and now the promise of humanity's future among the stars. For as long as we have stared into space, Mars has felt familiar, almost reachable, unlike the distant gas giants or the scorching hellscape of Venus. Today, after decades of robotic exploration, cutting-edge science, and bold engineering, we know one undeniable truth: Mars is the single best choice for human colonization in our entire solar system. It is not just a planet we study from afar. It is the world we are actively preparing to live on, work on, and build a new civilization upon. This is the epic story of the Red Planet, and why it will be humanity's first true home beyond Earth. Let us start with the basics that make Mars stand out from every other celestial body near us. Mars is often called the Red Planet because its surface is covered in iron oxide, the same compound that gives rust its color. This fine red dust blankets every crater, valley, and plain, creating a landscape that looks both alien and eerily similar to Earth's deserts. It is a small planet, about half the diameter of Earth, with just 15% of Earth's volume and 11% of its mass. But size is not what matters for colonization. Habitability potential does, and Mars checks more boxes for human survival than any other planet or moon in our solar system. Billions of years ago, Mars was a vastly different world. It had a strong magnetic field, a thick atmosphere, rich in carbon dioxide, and vast oceans of liquid water that covered much of its surface. Rivers carved deep canyons, lakes filled impact craters, and rainfall shaped its terrain. Scientists believe this warm, wet Mars existed for more than 1 billion years, long enough for simple microbial life to emerge. Then, everything changed. Mars' core cooled, its magnetic field vanished, and the solar wind stripped away most of its atmosphere. Without a thick atmosphere to trap heat, the oceans evaporated or froze underground, and Mars turned into the cold, dry, barren world we see today. Even in its current state, the remnants of its watery past make it incredibly valuable for future settlers. Water is the most critical resource for human life, and Mars has it in abundance, locked up as ice at the poles, hidden under the surface in mid-latitude regions, and even trapped in mineral deposits. This water can be melted, purified, and split into oxygen for breathing and hydrogen for rocket fuel, eliminating the need to haul every drop of water from Earth. The distance between Earth and Mars is another game-changing factor for colonization. Every 26 months, the two planets align in a launch window that lets spacecraft travel between them in just 6 to 9 months. Compare that to Jupiter, which would take a minimum of 5 years to reach, or Saturn, which takes 7 years. Venus is closer, but its surface temperature hovers at 460 degrees Celsius, hot enough to melt lead, and its atmosphere is a toxic mix of sulfuric acid and carbon dioxide, making it completely uninhabitable. Mars, by contrast, has an average temperature of minus 60 degrees Celsius cold, but manageable with proper shelter and heating systems. The planet's thin atmosphere, just 1% the density of Earth, offers little protection from radiation, but engineers have already designed underground habitats and radiation-shielded modules to keep settlers safe. One of the most overlooked but vital advantages of Mars is its day length, known as a sol. A Martian sol lasts 24 hours and 37 minutes, almost identical to an Earth day. This means human settlers will not have to adjust their circadian rhythms to a drastically different schedule, unlike astronauts on the Moon, where a day lasts 29.5 Earth days. A consistent day-night cycle is essential for mental health, sleep patterns, and daily routines, making Mars far more livable long-term than any other space destination. Mars also has a tilt on its axis of 25.19 degrees, nearly the same as Earth's 23.5 degrees. This gives Mars distinct seasons, just like our home planet: spring, summer, autumn, and winter, each lasting about 6 Earth months. This seasonal rhythm will help settlers grow crops, plan resource collection, and maintain a sense of normalcy in their new home. Gravity is another critical piece of the colonization puzzle, and Mars has the perfect middle ground. Mars' gravity is 38% of Earth, strong enough to prevent the severe bone and muscle loss that plagues astronauts in zero gravity, but light enough to make construction, transportation, and movement easier for settlers. The Moon's gravity is just 16% of Earth's, too weak for long-term human health, while gas giants have no solid surface to stand on at all. On Mars, settlers will be able to walk, lift heavy objects, and live without the constant physical strain of zero gravity or the health risks of ultra-low gravity. This stable, moderate gravity is non-negotiable for building a permanent, self-sustaining civilization. Humanity's journey to Mars has been a long series of triumphs and setbacks, pushing the boundaries of space exploration with every mission. The first successful flyby of Mars came in 1965, when NASA's Mariner 4 sent back 21 blurry black and white images of the planet's cratered surface, shocking the world with its barren, moon-like appearance. In 1976, NASA's Viking 1 and Viking 2 made history as the first spacecraft to land safely on Mars and send back panoramic photos of the red soil. The 2000s brought the twin rovers Spirit and Opportunity, which far outlasted their 90-day missions. Opportunity operated for an incredible 14 years, exploring craters and discovering definitive proof of ancient liquid water. In 2012, the Curiosity rover touched down, equipped with a suite of scientific instruments to study Mars' habitability, and it found organic molecules and clay minerals that formed in neutral water key signs of a once habitable environment. The most groundbreaking mission to date is NASA's Perseverance rover, which landed in 2021 in Jezero Crater, an ancient lake bed. Perseverance's primary goal is to collect rock and soil samples that will one day be returned to Earth by a future mission, allowing scientists to search for fossilized signs of ancient microbial life. It also carried Ingenuity, the first helicopter to fly on another planet, proving that powered controlled flight is possible in Mars' thin atmosphere, a game-changer for future aerial exploration and cargo transport. These missions are not just about science. They are about laying the groundwork for human arrival. Every rover maps the terrain, tests for resources, and studies the environment, solving one problem at a time for future settlers. The case for Mars, as our colonization top pick, only grows stronger when we look at the practical challenges of settling other worlds. The Moon is a valuable stepping stone, but it has no atmosphere, no liquid water, and extreme temperature swings from -173 degrees C to 127 degrees C. It is a great place for a research base, but not a self-sustaining colony. Venus is a death trap, as we have established, and the outer solar system's moons, Europa and Enceladus Titan, are too far, too cold, and lack the practical resources for large-scale human settlement. Mars is the only planet that balances proximity, resources, gravity, and day-night cycle into a feasible home for humanity. Building a colony on Mars will not be easy. Settlers will face global dust storms that can cover the entire planet for months, blocking sunlight and challenging solar power systems. They will need to grow food in hydroponic farms, since Martian soil contains toxic perchlorates that make it unsafe for plants. They will live in sealed habitats, recycling air, water, and waste to survive. But every challenge has a solution, and scientists and engineers are already solving them. NASA is developing closed-loop life support systems that recycle 99% of water and air. Private companies like SpaceX are building the Starship, a reusable rocket designed to carry 100 people to Mars in a single trip, with the goal of establishing a self-sustaining Mars city by the 2050s. International space agencies, including the European Space Agency, China's CNSA, and India's ISRO, are all collaborating on Mars exploration, uniting humanity around a common goal. Beyond survival and practicality, Mars represents something far greater for humanity. It is our chance to become a multi-planetary species, ensuring that our civilization does not depend on a single planet. Earth faces countless threats: asteroid impacts, supervolcanoes, climate change, and global conflict. A Mars colony would be a backup for humanity, preserving our culture, science, and diversity for millennia to come. It is also a frontier that will push us to innovate, invent, and grow as a species. Every technology we develop for Mars, sustainable energy, closed-loop, life support, radiation, shielding off-planet agriculture, will improve life back on Earth. Mars is more than a planet. It is a beacon of hope. It is the answer to the age-old question, where do we go next? For thousands of years, we looked up at the red dot in the sky and wondered. Today, we are planning our arrival. We are building the rockets, designing the habitats, and training the astronauts who will be the first to call Mars home. Of all the worlds in our solar system, none are as accessible, as resource-rich, or as welcoming as the red planet. Mars is not just our best choice for colonization, it is our only realistic choice for a future among the stars. Please like, comment, share, and subscribe to the channel.